Next problem. If A is equal to 211, 321, 212, then find A inverse. How to find inverse of any matrix? See, we have A inverse is given by 1 by det A into adjoint A. 1 by det A into adjoint A. So here, first we need to find determinant of that matrix and adjoint. So 1 by det A into adjoint A, that will give A inverse. Now, how to find that det of that matrix A? See here, determinant of matrix A. The 2 1 1, 3 2 1, 2 1 2. So expanding along first row, we will get 2 into 2 1 1 2 minus 1 into 3 1 2 2 plus 1 into 3 2 2 1. How to find determinant of any matrix? So we have definition. It is the sum of the products of elements of any row or any column with corresponding cofactors. It is the sum of the products of elements of any row or any column with corresponding cofactors. So what is meant by cofactor here? See here, cofactor. Cofactor of any element Aij is given by minus 1 whole power I plus j into minor of Aij. Minor of Aij. See again here, what is meant by minor? Minor of any element. See here, minor of any element Aij is obtained. It is the det of square submatrix. Square submatrix obtained by eliminating corresponding row and column. By eliminating so minor of any element, it is the det of square submatrix obtained by eliminating corresponding row and column. Suppose we want to find the minor of 2. Minor of 2. So to get minor of 2, eliminate first row and first column. That eliminate corresponding row and column. 2 is the element of first row, first column. So eliminating first row and first column and finding det of square submatrix. So eliminating first row and first column, we will get a det of submatrix like this. Is of 4 minus 1, that is equal to 3. So minor of 2. Similarly, if you go for minor of element 3, this element, minor of this element 3 is given by here. It is element of second row, first column. So eliminating second row and first column and finding a det of remaining square submatrix 1 2 1 1 1 2. So that will give 2 minus 1 into 2 minus 1 into 1. We will get 1. So like this we will get minus. Now cofactors. How to find cofactors of elements? To find cofactors, see here, cofactor of element 2 is given by, cofactor definition is cofactor of any element Aij is given by minus 1 whole power I plus j into minor of Aij. So we will get minus 1 whole power I plus j. 2 is element of here, 2 is element of first row, first column. We will get 1 plus 1 into corresponding minor of 2. Minor of 2 is, we found that minor of this first element 2 is 3. So we will get cofactor of 2 is 3. Cofactor of 2 is 3. Similarly, what is the cofactor? Cofactor of the element 1, this element 1 is obtained by applying minus 1 whole power 1 plus 2. That is the element of first row, second column. So I value 1, j value 2 into corresponding minor. What is the minor of 1? This element 1, eliminating first row and second column, finding that of remaining square submatrix. So we will get a minus 1 into 6 minus 2, that is equal to 4. We will get minus 4. Similarly, minor cofactor cofactor of element 1, that element 1 is given by minus 1 whole power. The position of that element 1 is that is the first row third column. We'll get 1 plus 3 into corresponding minor, eliminating first row and third column, you will get 3 2 2 1. That is the data of square submatrix obtained by eliminating corresponding row and column. So you will get here plus 1 into 3 minus 4, that is equal to minus 1. So like this we can find cofactors of elements. So now see, if you see the determinant here, it is the sum of the products of elements of any row or any column with corresponding cofactors. See here that 2 1 1 1 2 1 1, these three elements of first row. I'm taking elements of first row. You can take elements of any row or any column. Taking in general, we'll go for elements of first row, multiplying with the corresponding cofactors. So cofactors, see here 1 2 1 1 2. Here the cofactor of sign of cofactor will be here plus. That's why I'm taking here plus symbol. For the second element, sign of cofactor is minus. We'll get minus here. So I'm taking here minus symbol. The sign of cofactor of the third element is again positive. That's why I'm taking here positive. So it is the sum of the products of elements of first row with the corresponding cofactors. So if you simplify this one, we'll get 2 into 4 minus 1 3 minus 1 into 6 minus 2 4 plus 1 into 3 minus 4 minus 1. So we'll get 6 minus 4 minus 1. So we'll get 1. That is the determinant of that matrix. Determinant of that matrix is 1. But we need to find here inverse. So to find inverse, we have to go for adjoint A also. So we got finally det A value as 1. Now to find det A value, we have one shortcut method, that is 2 1 1. Write the elements first, 3 2 1 2 1 2. Elements of that given matrix. Now repeat the first column, 2 3 2 1 2 1. Now multiply along these diagonals. Multiply along these diagonals. It will give, so 2 into 2 into 4, 2 into 2 into 2, 8 plus 2 plus 3. So add these three, we will get 13. Let it be x. Now again multiply along these diagonals. Multiply along these diagonals. That will give 6 plus 2 plus 4. So we'll get 12. Let it be y. Now x minus y, that will give determinant of that matrix. 13 minus 12, that is equal to 1. So that is a shortcut method to find determinant of any 3 by 3 matrix. So we got determinant value 1. Now we need to find adjoint A. So adjoint A is given by transpose of cofactor matrix. Transpose of cofactor matrix. So we have to find out cofactor matrix. After that, take the transpose of that cofactor matrix, that will give adjoint A. Now see here, what about cofactor matrix? How to get cofactor matrix? So to find cofactor matrix, see, it is the matrix obtained by cofactors of that element, that matrix. It is a matrix obtained by cofactors of elements of that matrix. See, it has 9 elements, so we get 9 cofactors. See, we see the cofactor of that first element 2, cofactor of that first element 2. So we'll get, see, before going cofactors, we'll first I will assign signs here, plus, minus, plus. These are the corresponding signs of cofactors. Minus, plus, minus, plus, minus, plus, plus, minus, plus. So by applying that formula, minus 1 whole power I plus j, where I indicates corresponding row number, j indicates corresponding column number, we'll get these signs of cofactors. Now we'll go for minors. Cofactor is the signed minor. I said cofactor of any element aij is equal to minus 1 whole power I plus j into minor of aij. So now if we see that for first two element corresponding minor is eliminating first one, first column will get 4 minus 1 3. Next minor of 1, this element eliminating first row, second column 6 minus 2 4. Next minor of this element eliminating first row, third column will get 3 minus 4 minus 1. Next minor of this element 3 eliminating second row, first column, eliminating second row, first column will get 2 minus 1 2 2 minus 1 1, sorry. Next minor of this element eliminating second row and second column will get 4 minus 2 2. Next minor of this element eliminating second row and third column will get 2 minus 2 0. Next minor of this element 2 eliminating third row and first column will get 1 minus 2 minus 1. Next minor of this element eliminating third row and second column will get 2 minus 3 minus 1. Now for this element eliminating third row and third column will get 4 minus 3 1. So this is the corresponding cofactor matrix. We'll get 3 minus 4 minus 1 minus 1 2 0 minus 1 here minus of minus plus 1 1. Now to find adjoint A we need to find cofactor matrix whole transpose. So 3 minus 4 minus 1 minus 1 2 0 minus 1 1 1 whole transpose is given by 3 minus 1 minus 1 minus 4 2 1 minus 1 0 1. So this is the adjoint A. Now A inverse is given by 1 by det A into adjoint A. So already we found that det A value is 1 by 1 into adjoint A 3 minus 1 minus 1 minus 4 2 1 minus 1 0 1. So that is equal to, we'll get finally 3 minus 1 minus 1 minus 4 2 1 minus 1 0 1. So this is the inverse of that given matrix. Now we'll do a shortcut method to find the adjoint of any given matrix. See here. First write down the elements of given matrix. This is a given matrix. We need to find the adjoint of this matrix. 2 1 1 3 2 1 2 1 2. Repeat the first column here 2 3 2. Repeat the second column 1 2 1. Now at the bottom repeat the first row completely 2 1 1 2 1. Repeat the second row 3 2 1 3 2. Dividing like this, and now I will give the adjoint A like this directly. Adjoint A is given by, first find out det of this matrix 4 minus 1 3. Next come down, det of this matrix 1 2 1 1 is 1 minus 2 minus 1. Here write row wise. Next det of this matrix 1 1 2 1, 1 minus 2 minus 1. So that completes the first row. Now to get the elements of second row, first find det of this matrix. We'll get 2 minus 6 minus 4. Next det of this matrix 2 2 1 2, 4 minus 2 2. Next det of this matrix 1 2 1 3, 3 minus 2 1. Next that completes the second row. Now to get the elements of third row, finding det of this matrix 3 3 2 2 1, 3 minus 4 minus 1. Next 2 1 2 1, determinant value 0. 2 1 3 2, 4 minus 3 1. So that will give the adjoint A using a shortcut method. And now next problem is a given A matrix 1 0 0 0 0 1 0 1 0, we need to find A inverse. Here, see the special type of problem. Here no need to go for a regular procedure. We can find A inverse directly without applying any procedure. See here the correct, let us say I3. What is I3? We know that I3 is equal to 1 0 0 0 1 0 0 0 1. So it is a matrix obtained from I3 by interchanging second row and third row. By interchanging second row and third row, R2, R3. So if a matrix obtained from identity matrix by interchanging any two rows or two columns, then to find inverse of that matrix is itself. You can say that A inverse is itself again A. So inverse of any matrix obtained by interchanging any two rows or two columns of identity matrix is itself. So no need to go for a regular procedure.